We're now doing derivatives of a to the x and log base a of x. So they're saying let this function f of x be this. Then we're asked to find f prime of x. Notice that we have a logarithm right here. So let's go ahead and write out what the derivative of a log is. So we would say log base a of x. All right. And then this is true where your a is positive or greater than 0, and in this case, a cannot be equal to 1. Okay, so what's this equal to? It's 1 over natural log of the base, which would be a, and then all of this is times x. Okay, so times x. So 1 over natural log of a times x. Now, anytime we have something like this, we want to try to do our best to put this in our memory. So the key to notice here is the base is inside the natural log, and then we're times by x. So it's just kind of memorizing this form. There's no real easy way to do it. All right, so just do your best. Now, when we look at this, so when we do the derivative, so we're basically doing the derivative of 5 log base 2 of x, the constant moves out front. So that doesn't even play a part in here. So basically, we're focusing on the log base 2 of x. So all of this is going to be equal to, we have the 5, and then what is the derivative of log base 2 of x? Well, it's going to be 1 over, and I'm not even looking at this over here. I'm just kind of focusing, trying to remember. It's the natural log of the base, which is 2, and then we're multiplying by x. Okay, which is that x right there. All right, so then I'm just going to simplify. It's going to be 5 over, I like putting my x out in front so it doesn't look like it's part of the logarithm, times natural log of 2. All right, let's see if any of those match. 5 natural log of 2 times x. There we are. Okay, so that's going to be our strategy here. All right, now we got the other one to deal with. All right, so first we would want to say that what is, let's go ahead and just look at the answer. So we're asked to find the derivative of this function, and notice that we have an exponential function in here. Exponential function, the letter is in the exponent. That's why this is an exponential function, because x is in the exponent. Exponential function. All right, so we're doing the derivative, and this is this case here. So d dx of a to the x. Now, this is another formula. This is equal to the natural log of the base, natural log of a, times, and then we just rewrite this exponential function, a to the x. So both of these have natural log of the base in them, and then it's just a matter of keeping track. So this is multiplied by a to the x. Okay, so when we do this derivative with respect to x, of this function of negative 4 times 5 to the x. Once again, this constant does not play a part. So we would look at that as moving out in front. And then basically we're just focused on the derivative of 5 to the x. So this is going to be equal to the negative 4. And then what is the derivative of 5 to the x? It's the natural log of the base, which is 5. And then I just rewrite all of this. So that would be 5 to the x. Okay. I also forgot, this is also where a has to be greater than 0. So I just want to make sure that we have that caveat or have that justification in here. All right. So then now I'm going to go ahead and simplify this. Doesn't look like there's much that needs to be simplified. Negative 4, order doesn't matter with all multiply. So I like having my natural log at the end, so I don't have to worry about extra parentheses. All right, and all of this is multiply. Let's see which one of these matches. All right, negative 4 times, there it is, negative 4 times 5 to the x times natural log. Now notice that they multiplied here. We cannot do that. Of course, if you just calculated this, put this on a calculator, like put in the number 2 right here, that's going to give you a very different answer than negative 20 to the second power. All right, so totally different. Those are definitely not it. All right, and we're dealing with the natural log on these. Okay. All right. Next one. So this one looks exactly like the same kind of problem. Be careful. Don't do this in your head. As you're doing these problems, practice the formula. Write the formula out every time you do it. And then remember, my advice is try to do it from memory first and then check with a reliable source after you've tried on your own to actually use your memory. And all of them will be similar to these.